Good morning everyone. I am Dinesh Lakawat from the IT department section A. Today I am going to tell about the subject essential of problem solving. So let us get into our topic. Today's topic is the palindrome permutation. Introduction to palindrome permutation. A palindrome is a word or a phrase that reads the same forwards and backwards. Palindrome permutation involves rearranging letters to form a palindrome. Understanding this concept helps in solving various string and pattern problems in computer science. What is a palindrome permutation? It is a rearrangement of characters in a string to form a palindrome. Not all strings are palindromes, but some can be permuted into one. The goal is to determine if such a permutation is possible for a given string. Why to study palindrome permutations? They are fundamental in understanding string manipulation. They have applications in cryptography and data validation. Studying them enhances problem solving skills in coding interviews. There are some basic rules for palindrome formation. For strings of even length, all characters must occur an even number of times. For strings of odd length, only one character can appear an odd number of times. Other characters in the string must occur in pairs or be adjusted accordingly. These are some basic rules for palindrome formations. Yes. Approach to detect palindrome permutation. Count the frequency of each character in the string. Check the number of characters with odd counts. Determine if the string can form a palindrome based on these counts. Counting character frequencies. Use a hash map or dictionary to tally characters efficiently. Ignore spaces or non-alphabetic characters if necessary. The frequency count helps to identify potential for palindrome formation. Checking odd counts. Count how many characters have an odd numbers of occurrences. For even length strings, this count should be 0. For odd length strings, this count should be at most 1. Algorithm summary. Count each character's frequency. Count how many characters have odd frequencies. Return true if the counts meet criteria for a palindrome permutations. Implementation in Python. Use a dictionary to store character counts. Loop through the string to update counts. Check the number of odd counts to determine the result. Implementation in Python. Use a dictionary to store character counts. Loop through the string to update counts. Check the number of odd numbers to determine the result. Example 1. Civic. Count characters. C2, I2, V2. Only one character V has an odd count. Since the string length is odd, it can be rearranged into a palindrome. Example 2. IVICC. Counts. I equal to 2, V equal to 2, C equal to 2. No characters with odd counts. The string can be permuted into civic or VICIC. Example 3. Hello. Counts. H equal to 1, E equal to 1, L equal to 2, 0, O equal to 1. Three characters are odd counts. Since more than one character is odd, it cannot be permuted into a palindrome. Edge cases to consider. Empty strings are trivially palindromes. Strings with all identical characters are always palindromes. Strings with spaces or punctuation may need normalization before checking. Edge cases to consider. Empty strings are trivially palindromes. Strings with all identical characters are always palindromes. Strings with spaces or punctuation may need normalization before checking. Optimization techniques. Use a bit vector to track odd or even counts for faster checks. Early exit if the number of odd counts exceeds 1. Convert strings to lowercase to handle case sensitivity normally. Optimization techniques. Use a bit vector to track odd or even counts for faster checks. Early exit if the number of odd counts exceeds 1. Convert strings to lowercase to handle case sensitivity uniformly. Now let us talk some real world applications. Palindrome detection can be used in DNA sequence analysis, useful in chromatography for pattern recognition, applying linguistic studies for palindrome based language patterns. Common mistakes we do: forgetting to ignore non alphabetic characters or spaces, not handling case sensitivity, leading to incorrect results, misinterpreting the number of odd counts required for permutations. These are the common mistakes we do. Summary of key points. Palindrome permutation involves character count analysis. The key is the number of characters with odd frequencies. Efficient algorithms rely on counting and early terminations. Summary of key points. Palindrome permutation involves character count analysis. The key is the number of characters with odd frequencies. Efficient algorithms rely on counting and early terminations. Practice problems. Determine if AABBCC can be permuted into a palindrome. Check if race car is a palindrome or can be rearranged into one. Find if ABC can be rearranged into a palindrome. Practice problems. Determine if AABBCC can be permuted into a palindrome. Check if race car is a palindrome or can be rearranged into one. Find if ABC can be rearranged into a palindrome. These are some practice problems you can do. Now let us conclude our topic. Conclusion and further readings. Palindrome permutation is a fundamental string problem with board applications. Mastery of counting techniques aids is solving related algorithm challenges. Explore more about string manipulation and pattern recognition for advanced topics. Conclusion and further readings. Palindrome permutation is a fundamental string with a bold applications. Mastery of counting techniques aids in solving related algorithmic challenges. Explore more about string manipulation and pattern recognition for advanced topics. So, with this, our topic is concluded. Thank you for listening my topic